So if you read the problem, we've been given that the camera is right here, right? The distance between the camera and the launch location is about 2,000 feet. The height is how much this rocket has been launched, right? We can find the height. Because they're telling us that 10 seconds after liftoff. So we can find the height. The height S would be basically 50 times 10 squared, right? So that's 5,000 feet. Now the question is asking us to find what? They want us to find the rate of change in the angle of elevation of the camera shown in figure 2.37. So they want us to find the rate of change of the angle of elevation here, okay? So what do we know? There's a lot of things that we can use here. Again, we're gonna go back to the right triangle, right? We know that ds over dt will be equal to what, according to this? How do you find ds over dt? The rate of change of the height. If you have the function has been given is 50t squared. It would just be 100 times t, right? Right? And they want us to find what? d theta over dt. The angle of elevation. This is the angle of elevation. Okay? That's what they want us to find. Questions? They want us to find this angle of elevation. What can we use here? What do we know about a right triangle? What do we know about a relationship? Go back to your angles and Pythagorean theorem and stuff like that. We know that tangent is what? Adjacent over opposite over adjacent, right? Tangent of this angle what? Will be opposite over adjacent. Any questions? You remember that? Okay, so tangent of theta will be what? Opposite, which is s over adjacent, right? 2,000. Now, I want to find d theta over dt, so I need to find the derivative here, right? What's the derivative of tangent theta? What's the derivative? Tangent of x. What's the derivative of tangent? Secant x, tangent x, right? So this will be secant theta, tangent theta, right? Times what? One more thing, d what?
D
over dt, right? Equals to, what's the derivative of s? This is, we can pull out the 1 over 2,000, right? So what's the derivative of s? Amy. What's the derivative? Just s. What's the derivative of s? 1 times what?
ds.
ds over dt, right? ds over dt. And now we're solving for d theta over dt. So we solve for d theta over dt. So that's just going to be 1 over 2,000, right, times ds over dt, the whole thing over secant theta tangent theta. Now, we are not done just yet, okay? Now we need to find ds over dt when t is equal to 10 seconds. That's what it told us. We also need to find secant theta, and we also need to find tangent of theta, okay? We also need to find these pieces. Aiden, hold on a second. Let me double check. Is the derivative of tangent theta secant?
I
No.
thought it was secant squared.
Secant squared. Oh my goodness. This is terrible. Alright, let's fix it. Yeah, I knew someone wasn't right. So, secant squared, right? So it's going to be secant squared theta times d theta over dt. Okay? So that's the only thing that changes. And then to find d theta over dt, it's going to be 1 over 2,000 times ds over dt, the whole thing over secant squared theta. Now we need to find secant squared theta, we need to find ds over dt, okay? So, ds over dt would be basically 100 times 10, okay? Because we're doing it 10 seconds after liftoff, right? So that would be 1,000. So go back here, this is 1 over 2,000 times 1,000 over secant square of theta. Now we need to find secant square of theta, right? I know that secant theta is 1 over what? 1 over cosine of theta, right? That's just by definition, okay? So cosine of theta is what? How do you find cosine of an angle? Yes?
It's adjacent over.
Adjacent of our hypotenuse, right? So cosine will be adjacent, which is basically 2,000 over hypotenuse. We need to find the hypotenuse, right? We need to find it. So to find it, we're gonna use again the Pythagorean theorem here, right? So we know that cosine of this angle is adjacent over hypotenuse. We need to find the hypotenuse. We know that this is 2,000 feet. This is 5,000. We need to solve for the hypotenuse. Okay, hypotenuse will be squared will be s squared times 2,000 squared. So that's 2,000 squared plus s squared, which is 5,000 squared, right? Can y'all put that in your calculator? 2,000 squared plus 5,000 squared, and then find the square root of that and tell me what it is. So do 2,000 squared plus 5,000 squared, and then take the square root of all of that once you finish it. What'd you get? 5,385.16. All right. And now to find cosine, you do 2,000 over 5,385.16. So tell me what that gives you. Get it? What you get? 0.37. Cosine theta is 0.37. But we're looking for a secant. So secant will just be taking the inverse of this, right? So secant of theta will be 1 over 0.37. So what's that going to give you? $2.7, all right, 2.7. And now we just go back here and just replace stuff. So it's 1 over 2,000 times 1,000 over 2.7 squared, because it's secant squared, and that should give you the change in the angle. So d theta over dt. Okay, so that should give you that. Just plug that in your calculator, and whatever you get, that's the answer. It's just a long process, and then recognizing the Pythagorean theorem, because we're using the right triangle, knowing that this is the tangent is opposite of adjacent, and then to solve this, we use again the same identity: a squared plus b squared equals to c squared, and then applying our implicit.